Good evening, everyone. Welcome back to another session of our faculty development program. As we approach the conclusion of another enriching day, we have an exciting session lined up for you. It is my privilege to introduce our distinguished speaker for this session, Dr. Premanand Singh Chauhan. Dr. Premanand Singh Chauhan is currently serving as the Pro Vice Chancellor of Vikrant University, Gwalior, and as an advisor to Gayatri Auto Industries. Previously, he held the position of director at Sushila Devi Bansal College, Indore. He has also worked at IPS College of Technology and Management in various roles, including principal, dean, and associate professor. Additionally, he served at Sri Ram College of Engineering and Management, Banmore, Gwalior, in capacities such as lecturer, assistant professor, head, dean, and director academics. Dr. Chauhan graduated as a mechanical engineer in 1994 from the Madhav Institute of Technology and Science, Gwalior. He earned an MTech in production engineering from the same institution and later completed his PhD in mechanical engineering at the Maulana Azad National Institute of Technology, Bhopal. With 26 years of professional experience in teaching, training, and research, Dr. Chauhan has devoted 19 years to administrative and academic roles while gaining 7.5 years of industrial experience. He has organized over 25 government funded faculty development programs, short term training programs, and webinars, and has delivered numerous lectures at various FDPs. Dr. Chauhan has authored or edited 12 books and proceedings published by renowned international publishers including Elsevier, Taylor and Francis, and IOP. He holds 2 patents and has published 61 research papers in national and international journals and conferences. He has successfully supervised 17 MTech dissertations and is currently guiding 8 PhD scholars. Dr. Chauhan has also managed several consultancy and research projects. Dr. Chauhan is a life fellow member of the Institution of Engineers, Kolkata, and a life member of the Indian Society for Particle Accelerators in ISPA, Indian Society of Mechanical Engineers, ISME, IIT Delhi, Indian Society for Technical Education, IST in New Delhi, and the Indian Institute of Welding, Kolkata. He is also a member of the International Association of Engineers, Hong Kong. He serves on the advisory boards of several international journals and is the editor-in-chief of the International Journal of Artificial Intelligence, Internet of Things, and Cloud Computing, and the International Journals on Materials, Mechanics, Mechatronics, and Manufacturing. Additionally, he is a guest editor for Scopus Index journals such as Engineering and Computational Mechanics and the Journal of Micro Manufacturing. As a reviewer, Dr. Chauhan contributes to several prestigious international journals, including the Australian Journal for Mechanical Engineering, Journal of Mechanical Science and Technology, American Journal of Mechanical Engineering, and Journal of Institution of Engineers, among others. Dr. Chauhan has received numerous accolades, including the Director of the Year Award 2022 by Universal Mentors Association India, and a certificate of recognition from the Academic Council of ULEX as one of the exemplary academic administrators of higher education institutes in India 2019. He was also honored with the Excellence Award 2015 for reducing in-process manufacturing non-conformities in machined components by Gayatri Auto Industries, Gwalior. His areas of interest includes product design, optimization, and machine design. Dr. Chauhan has traveled extensively for academic and professional purposes, visiting countries such as the USA, Malaysia, and Thailand. In this session titled Recent Advancements in Manufacturing Process for Industrial Evolution, Dr. Chauhan will explore the latest advancements shaping manufacturing processes and their profound impact on the ongoing industrial revolution. From automation to smart manufacturing, this session will provide invaluable insights into the future of manufacturing technologies. Dr. Chauhan, we are eager to hear your expertise and learn about this advancement. The virtual stage is all yours. Over to you, sir.
Thank you, Harshita madam. I think it is not the brief introduction. It is too long introduction. Just I am sharing my slide first. And please let me know my presentation is visible or not. Could
Yes.
you please
Yes,
confirm? Mhm. Okay.
yes, it's visible.
Thank you, madam. Thank you. Should I start?
Yes, sir.
Yes. So, management of the SAGE and Parul University. Coordinators, both coordinators, Dr. Kirti Jain and Dr. Anup Agarwal, professors, delegates, colleagues, and participants. Very good evening to you all. Before starting my presentation, I express my heartfelt gratitude to SAGE and Parallel University. A special thank you to both coordinators for giving me platform to interact with you all. The topic of FDP is next generation manufacturing, harnessing digital technologies for industrial transformation. Really, it is a demand of the era. I appreciate both coordinators for conceptualizing this topic. I was reviewing the schedule, various topics, including virtual manufacturing, design for sustainability, AI-enabled manufacturing, an overview of Volvo Eicher by Sachin Sir, micro manufacturing, smart factories, and Indian semiconductor just completed by the Sumedha ma'am by various experts. My topic of today's presentation is advancement in manufacturing processes, industrial revolution, aligned with the FDP. I would like to acknowledge my student also who supported me to prepare this presentation, Mr. Ankit, Mr. Satyajit, and Ms. Nikki Tomar. Their experience and expertise in the industry where they are actively working have provided valuable insight into technological advancements. I would also like to extend my gratitude to Gayatri Auto Industries, from where I sourced the data used in this presentation. I would like to mention that, and because several industrial segments involved there, that this presentation is purely for academic purpose only. No industrial work and no commercial work is permitted with this presentation. If we talk about the overview of my presentation, yes, that first we will focus that begin with the discussing from industry 1.0 to 5.0 with a focus on how global GDP has changed over time and the contribution of different sectors to this growth. Also focus on adverse effects of industrial revolution 1.0 to 4.0. However, as we examine the advancement of these revolution, it is also important to consider the adverse effects such as environmental damage, inequality, and the displacement of workers that have been accompanied each stage. I will try to cover it. At last, we will focus on Industry 5.0, a shift towards human-centric innovation. And then finally, we'll conclude with some key takeaway from this journey through the industrial revolutions. Dear participants, in this slide, I will present the timeline of the different industrial evolutions and highlights major technological advancements. During the first industrial revolution, water power and steam power were used to operate machines. Earlier, it was manual. It means we shifted from craftsmanship to mechanized system. In the second industrial revolution, the focus shifted to mass production assembly line and use of electric power. Moving further, with the limitation of mass production machines and the developments of computer and automation systems, machines begin to be operated with computers. Later advancement in IT systems facilitated the transition to IoT-enabled devices. From Industry 1.0 to 4.0, technology evolved with minimal focus on human well-being, environmental concern also, and sustainability. However, these aspects are now central to Industry 5.0. As it is marked in the slide, in 1780, we were in Industry 1.0. After 120 years, we transitioned to Industry 2.0. 70 years later, Industry 3.0. And then 30 years later brought us to Industry 4.0. And just 20 years later, we are preparing to embrace Industry 5.0. The key point to highlight here is the timeline. It is evident that the transition periods are becoming progressively slower, reflecting rapid technological advancements and their role in driving exponential growth in GDP. In this slide, we are interested to present the relevant data regarding growth in global GDP. Around 1780, the global GDP was approximately $1 trillion USD. Over the preceding 1700 years, it had gradually increased from zero point 0.2 trillion to 1 trillion USD. However, from 1780 to the present, the global GDP has skyrocketed to 140 trillion US dollars, representing a 140-fold increase according to data from the Our World in Data website. The industrial revolutions have been a key driver of this exponential growth in the global GDP. This growth is not solely driven by the manufacturing sector, but also includes significant contribution from the service sector and agriculture also. There are some other sectors also. It is evident that over the past 10 years, the service sector has contributed approximately 60% to the global GDP, while the industrial sector accounts for 25% and agriculture contributes around 4%. Hence, the industrial revolution have not only influenced the manufacturing sector, but also impacted other segments significantly. The industrial revolution extends beyond manufacturing to include energy, communication, transportation, society, economy, health, environment, education, and ethics also. Each era has introduced profound changes, reflecting humanity's evolving needs and aspirations. Industry 5.0 emphasizes a holistic, sustainable, and human-centric approach, integrating advanced technologies to enhance the well-being of society and the planet. If we talk about the next 6 slides, I will try to focus on the key innovations and impacts of the industrial revolutions across various sectors. The core aspect, that means in manufacturing and production. Each industrial revolution brought significant advancements in processes, making manufacturing more efficient and scalable. The key innovations from Industry 1.0 to 5.0 includes steam engines in 1.0, assembly lines and electricity in 2.0, automation and robotics in 3.0, smart factories in 4.0, and human-centric collaboration in 5.0. These innovations have led to enhanced productivity, cost efficiency, mass production, and the ability to achieve greater customization. In the energy and resource sector, we transition from steam and coal in 1.0 to electricity in 2.0, fossil fuels in 3.0, renewable energy resources in 4.0 and 5.0. This progression has resulted in improved electricity, improved energy efficiency, reduced environmental impacts, and the development of smart energy management systems. Further, in Industry 4.0 and 5.0, there has been a strong emphasis on green energy and sustainable resource utilization. In communication and information technology sector, the telegraph emerged in Industry 2.0, followed by computers and early network in Industry 3.0, and IoT, cloud computing, and AI-driven communication systems in Industry 5.0, 4.0, and 5.0. These innovations have enabled real-time global connectivity, digital collaboration, and seamless information exchange. In transportation and logistics, steam engines played a major role in the revolution of train and ships. During Industry 1.0, automobiles and airplanes emerged in Industry 3.0, while automated logistic systems began in Industry 3.0. Industry 4.0 and 5.0 introduced autonomous vehicles, drones, and smart supply chains. These advancements have resulted in faster, more reliable transportation and a highly globalized supply chain. In economy and trade, we shifted to localized economic and trade in 1.0, mass production and urbanization driving industrial economics in 2.0, globalized trade and multinational corporation in 3.0, digital and knowledge economics in 4.0 and 5.0. These shifts impact economic growth, the creation of new industries, and the transformation of the labor market. If we talk about society and workforce, manual labor dominated in 1.0. Skilled workers, especially required for the mass production machines, operated mechanized system in 2.0. Programmers and technicians managed automated systems in 3.0, especially for the CNC machine and C machines. Data scientists and technology managers emerged in 4.0, and creativity driven roles and ethical leadership characteristics in 5.0. These changes impact job displacement in some area. Glad to share that growth in urbanization and infrastructure. Industry 1.0 is sparked the first wave of urbanization with factory hubs. Industry 2.0 improved urban planning with electricity and public transport. Industry 3.0 introduced smart infrastructure concepts. Industry 4.0 and 5.0 emphasize smart cities with connected systems. Its impacts include population shifts, improved living standards, and advanced infrastructure developments. Dear participants, if we talk about the health and medicine segment, the improvement include better sanitization and water systems during Industry 1.0 and 2.0. Diagnostic tools and biotechnology in Industry 3.0, and telemedicine, personalized medicine, and wearable health devices in Industry 4.0 and 5.0. The impacts in this sector are increased life expectancy, better healthcare access, and preventive care also. In environmental and sustainability, the identified progress includes resource-intensive and polluting practices in Industry 1.0 and 2.0, early environmental regulations in Industry 3.0, and sustainable manufacturing, circular economy, and green energy in Industry 4.0 and 5.0. The impacts are a growing focus on balancing industrial growth with environmental protection. In education and skill development, the changes in learning includes basic literacy from factory workers during Industry 1.0, vocational training from industry during 2.0, specialized technical education during 3.0, and digital literacy and interdisciplinary learning during 4.0 and 5.0. The impacts are lifelong learnings, a focus on STEM, and the integration of AI in education. As far as ethics and human-centric focus are concerned, this segment has also evolved significantly. Industry 5.0 places a strong emphasis on ethical manufacturing, human well-being, and the socio-economic impacts of technology. It focuses on balancing technological advancements with social responsibility and inclusivity. Dear participants, it is clear that technological development has been a hallmark of every industrial revolution, driving exponential growth in global GDP across various aspects and sectors. Hence, we may say that there are changes not only in manufacturing, but also in different segments also. In the Viking era, that is 800 to 1050 Common Era, in the core manufacturing machining sector, I am taking the example of the lathe machine because my expertise is in machining. And I am born and brought up in the family, that is industrial family, where my father had an industry under name of Gayatri Auto Industries. And that unit is the machining unit. That's why my example is mainly connected with it. The lathe machine is often considered the mothers of all machines. During the Viking era, the pole lathe emerged, operating on the same principle as the pole vaulting came. Energy was initially stored in a wooden pole, which was then used to power the machining process. The spring pole design was versatile. It could be made lightweight and portable, which was important for craftsmen traveling to areas where raw materials were abundant. It was relatively simple to construct and required few parts that craftsmen could not create themselves. However, there were drawbacks to this elegant design also, such as a relatively slow turning speeds and limitation on the size and weight of the object that could be turned. Process was slow and tedious. Despite these limitations, the spring pole lathe remained popular into the 19th century also, especially amongst chair makers and other traditional craftspeople. Throughout the medieval period, most lathes were spring pole lathe, though some advancement occurs. A significant improvement in lathe design was the conversion of the reciprocal back and forth motion of the pole lathe into continuous rotation. This innovation enabled faster turning speeds, allowed for the handling of longer and heavier objects, and made the turner's labor more efficient. It also facilitated the use of flywheel, a mechanism that stores energy and provides consistent speed and torque during the treadle's return stroke. In the late 15th century, Vinci made further contribution to lathe design. He illustrated a treadle-powered machine with a flywheel and a drive belt connected to a smaller pulley, stepping up the turning speed while reducing the operator's effort. This design allowed for much faster turning speeds and a less strenuous space for the operators. If we talk about the problems of the Industry 1.0, at the same time, we talk about the problems of that era. One of the main challenges during this era was the difficulty of removing materials from the steel and other hard materials using only craftsmanship and human power. These limitations led to the adoption of steam and water turbine to run machines starting in 1712. The first commercial successful engine capable of transmitting continuous power to a machine was developed in 1712 by Thomas. In 1764, James Watt made a critical improvement by channelizing spent steam into a separate vessel for condensation. This innovation significantly increased the efficiency of a steam engine, enabling more work per unit of fuel consumed. By the 19th century, a stationary steam engine powered the factories of the Industrial Revolution. Steam engines replaced sails on ship, example paddle steamers, and enabled steam locomotives to revolutionize railway transportation. Summarization of the Industry 1.0. Industry 1.0 marked the beginning of the transition from the manual craftsmanship to mechanization, powered primarily via the water and steam, as mentioned earlier. This era introduced mechanical production systems, how goods were manufactured. Significant technological innovation included the invention of a steam engine and the development of a spinning jenny and power loom also, which transformed textile production. The impacts of these advancements were profound. Factories emerged as center of production, creating urban workforce and giving rise to industrial cities. This period laid the foundation for the industrialization that would follow in subsequent revolutions. Engine lathe, it was also one of the major inventions. We talk about the Industrial Revolution 1.0. The invention of engine lathe by English inventor Henry in 1800 marked a significant milestone at that time. It was the first powered lathe to feature a lead screw, a mechanism that couples the rotation of the spindle to the movement of the carriage or tool holder. This innovation allowed for the precision cutting of accurate screws, laying the groundwork for standardized manufacturing processes. We are interested to demonstrate, share a video with you that is an old steam-powered machine shop of the late 1900. It will give you the overview of the old production systems.
Is that momentum, or are you just putting steam to it? Whoa. Yeah. No.
Yeah, this eccentric, this eccentric needs to be taken up just a little.
In the early of the 19th century or late 18th century, the entire workshop was run by a single power source. Nowadays, we are using a separate power
Okay, this is our
source for
second
each and every
trial run up.
machines.
We took 5,000 shim out of the eccentric and then we're hoping that'll get that little click out of it.
I'm forwarding the video and focusing on the main point of it. This lathe machine is operated by the steam engine. Nowadays, if we talk about the lathe machine, the lathe machine is being operated by the electric motor, that is induction motor.
This is actually a piece of scrap. We've cut off the end of it. A piece of bar stock, that's why the end is so bunged up. And it looks pretty good for this. I can do it where you can see it.
Now we talk about the second industrial revolution, which came to fruition by the end of the 19th century, marked a significant transformation in manufacturing processes. The key change during this era was the introduction of mass manufacturing, driven by the development of production lines powered by electrical energy. If we talk about the summary of it, as we discussed earlier, Industry 2.0 marked the age of mechanization from mass production and electrification. This era saw the introduction of electrical energy to power manufacturing processes, which significantly boosted efficiency. One of its key features was the adoption of assembly lines, enabling mass production on an unprecedented scale. Technological advancements during this period included the replacement of steam power with electric motors, transforming industrial capabilities. A major breakthrough was the creation of the first assembly line by the Henry Ford, which transformed automotive production and set new standards for manufacturing industries. If we talk about the impacts of Industry 2.0, it led to, that is transformative, it leads to increased production efficiency and reduced cost, paving the way for the emergence of consumer goods industries and making products more accessible to a growing population. The commercial use of electric motors, again, started in the same era, brought significant advancement in machining technology. The modern engine lathe, powered by an electric motor and equipped with a gearhead, provided variable spindle speed for rotation and precision. Accurate feed for tool movements was also the invention of that era. For mass production, the cam-operated single spindle automatic lathe machine was also developed during this era. This highly specialized tool was especially designed for precision manufacturing and especially machining. It operates on the principle of using cams to control the movement of the tool and the spindle. Pre-designed cam profiles dictated the machine's operations such as cutting, turning, threading, knurling, and number of operations are there. These machines became widely used in industries like automotive, electronics, watch manufacturing, etc., for producing small and intricate parts. Their ability to deliver high production rates with precise tolerances made them indispensable for tasks requiring accuracy and repeatability. However, these machines required skilled operators. Really, I faced because I was looking after that industry. I faced the same problem, skilled operators to design and set up cams for specific machining processes. Here are some videos showcasing various operations performed on single spindle automatic lathe machine. We may see here the drilling operation, chamfering operation, parting of operation are being performed with the help of the cam-operated lathe machine. The drilling operation is controlled by the cylindrical cam, while the feed for parting off and chamfering operation are managed by a disc cam. These all are the products. These products are being manufactured for the Eicher and Sonalika tractors. The thread rolling machine, developed in the same era, was another significant innovation aimed at mass production. Earlier, the threads were manufactured on the lathe machine, and it required approximately 30 minutes and 1 hour. And with the help of this machine, the time is decreased significantly. And you may watch here. So thread rolling machine was also the one of the important, we can say, the significant innovation of that era. This slide highlights the drawing of a component. That component is the adjusting screw and its corresponding finished product. As shown in the drawing, the product and adjusting screw was manufactured using the machine that we have seen just now. This demonstrates the capability of these machines to produce high precise component with repeatability. However, the era faced significant challenges. There was a shortage of skilled manpower to develop cutting tools and to design and set up cams for specific machining processes. Additionally, quality was a major concern due to wear and tear, as well as lack of advanced measuring instruments during manufacturing. This led to higher rejection rate and frequent replacement under warranty. Moreover, market pressure demanded reduced manufacturing cost without compromising on quality. I would like to mention that, as I marked earlier also, I was born and brought up in an industrial family. We have a manufacturing unit. We manufacture turned and forged component for Eicher and Sonalika. We are the vendor unit of Eicher and Sonalika. I have seen the transformation of the manufacturing unit of machining. When I was just 15 years old, my father taught me designing of tooling that include cutting tools and cams for cam operated lathe machine. That was the transforming phase from industry 2.0 to 3.0. It was not easy to understand all these segments, and it required special characteristics and regular practice in human being. The invention of this machine was a major development of industry 2.0, but too skilled manpower is required to set these machines. It may be considered as one of the problem, and definitely it was a driving force to use computers and electronics in the manufacturing sector. And with the integration of these technologies, CNC machine came into existence. As I discussed the challenges, these challenges was the advent of the computer numerical control technology, along with practices. One of the major practice in the industry that is in PPAP, that is production part approval processes, which standardized and improved production quality and efficiency. Now we are moving from industry 2.0 to industry 3.0. As industry 3.0, this marked the beginning of the third industrial revolution in the fourth quarter of the century. This era introduced electronics, programmable logic controllers, robots, and IT-driven systems to automate production. These advancements addressed earlier problems by increasing efficiency, ensuring quality, and minimum human error in manufacturing processes. We summarize the third industrial revolution. The third industrial revolution, also known as the digital revolution, introduced a transformative integration of electronics, information technology, and automation into manufacturing processes. This era saw the rise of computers and robotics, making a significant shift from mechanical system to digitally driven systems. Among its key technological advancement were, as I discussed, the development of PLC for automated control, enabling more efficient and precise production processes. Additionally, the introduction of the computer-aided design and computer-aided manufacturing, that is CAD and CAM, transformed product design and manufacturing by providing highly accurate and flexible systems. Moreover, this period emphasized quality management system also, which helped standardize processes and ensure higher level of product quality. Industry 3.0 led the groundwork for modern automation and digital manufacturing systems, pushing industries towards a smarter, more interconnected production. The impacts are enhanced precision and customization, reduction in human error, and increased products quality and shift towards lean manufacturing principles. Here, I'm interested to show a video of the CNC turning center. It will demonstrate the advancement in the machine. Earlier, if we talked about the manufacturing of the gear, I think it will take around, that is, 30 minutes or maybe 45 minutes. It depends on the size of the gear. But you may see here, the gear may be produced only with, that is within 10 minutes or within 6 minutes or 7 minutes or 8 minutes, depending on the size of the gear. Earlier, we were using only single spindle lathe machines. Here, we may see that at that time, we was we were using the dual spindle lathe machine also. That was the major innovation of that era. Now, we are interested to focus on the key contributors to the CNC manufacturing industry. These manufacturers have played a crucial role in automating production and driving precision engineering across industry. On an international scale, prominent manufacturers like Indextrop led the way with their high precision, innovative CNC solution that are recognized globally for their excellence. On the national front, that means if we talk about the contribution of the national industries, that means domestic industries, the pioneer in manufacturing sector was, is, and maybe in future also, this BFW, S, LMW, Jyoti Automation, KDE, and Lokesh. Some other industries are also there, but I tried to cover the companies, the lathe machine, which are being used, manufactured by the various companies and used in industries nowadays. These manufacturers have been instrumental in transforming the machining sector by providing robust, efficient, and precise CNC solution tailored to various industrial needs. I have added this slide intentionally because we talk about this presentation. From Industrial Revolution 1.0 to 3.0, we are interested to depict or develop a human. Means we are interested the working may be done like a human. So we must understand the human mind. But I think due to limitation of time, because as per schedule, I have only 30 minutes. So I am skipping this slide. But in future, whenever I will get the time, I will try to cover it. Now, I mainly focus on Industry 4.0. Building on the foundation led by Industry 3.0, which introduced automation, computerization into manufacturing processes. Industry 4.0 takes a revolutionary step forward. It leverages advanced integration of technologies such as cyber physical systems, the Internet of Things, and the power of big data, artificial intelligence, and cloud computing. Together, these elements create a truly interconnected and intelligent ecosystem. Dear participants, now let's explore the key features of Industry 4.0. The integration of CPS, that cyber physical system, and IoT ensures seamless communication between physical and digital systems, as I marked here, enabling dynamic interaction and real-time feedback. The use of big data and AI allows manufacturers to analyze vast amount of data, unlocking actionable insights for better decision making. If we talk about the cloud computing, it provides a centralized and scalable solution, enhancing collaboration across systems and locations. These features are supported by several technological advancements. Real-time monitoring enables business to observe production systems continuously, ensuring efficiency and minimizing errors. Additive manufacturing or 3D printing, nowadays it is common, is transforming prototyping and production by enabling rapid, cost-effective, and customized outputs. Predictive maintenance, powered by smart sensors, anticipates equipment failures before they happen, reducing downtime and operational cost. The impact of Industry 4.0 are profound. Manufacturing systems are now more flexible and efficient, adapting dynamically to market demands. Data-driven decision-making ensures that leaders make well-informed choices that enhance productivity and competitiveness. Additionally, sustainability is a key outcome with reduced waste and optimized energy consumption, contributing to environmentally friendly manufacturing practices. If we summarize it, in summary, we may say it, Industry 4.0 represent a paradigm shift in how we approach manufacturing, connecting people, processes, and technologies in ways that were unimaginable in Industry 3.0. It is not just about production, it is about transformation, innovation, and sustainability. Hence, we may say that manufacturing not in isolation, but as an integrative platform means that modern manufacturing is no longer limited to standalone processes or operations within a single facility or organization. Instead, it is interconnected and collaborative, involving integration across various systems, technologies, and stakeholders to achieve a seamless and optimized production system. If we talk about the cyber physical system, machine tool 4.0, otherwise known as the cyber physical machine tool, because the entire presentation is on the machine tool, that's the lathe machine, is the integration of machine tool, machining processes, computation, and networking, where embedded computers and networks can monitor and control the machining processes with the feedback loops in which machining processes can affect computations. Here, we are interested to depict the connection of the IoT and non-IoT devices on internet. If we talk about the 2003, the total world population was 6.3 billion, and the connected devices were 500 millions. And at present, that means 2024, the world population is 8.2 billion. But at the same time, the connected devices are around 22 billions. That means you can see how drastically the number of devices increase on the connection on the internet. We have seen the advancement in technology during Industry 1.0 to 4.0. Every development has another aspect also. Hence, the adverse effect of these revolutions should also be discussed. These adverse effects include environmental, social aspects, economic, and health-related challenges. If we talk about the environmental degradation is a critical challenge facing our planet today. It encompasses three key aspects: deforestation, population, and climate change. At the same time, pollution also. If we talk about the deforestation, the expansion of the industries and urbanization has significantly contributed to deforestation. As land is cleared for development, it leads to a loss of biodiversity, disrupting ecosystem, and endangering countless species. If we talk about the pollution, another major contributor to environmental degradation. It stems from the widespread use of coal and fossil fuels. This has led to severe air pollution, smog, and respiratory diseases. Additionally, industrial waste is often dumped into rivers and seas, resulting in water pollution and harming aquatic ecosystem. If we talk about the climate changes, lastly, the burning of fossil fuel releases vast amount of carbon dioxide into the atmosphere. This has accelerated the long-term effects of global warming, such as rising temperature, melting ice caps, and extreme weather conditions. In conclusion, we may say that these interconnected issues demand urgent action to preserve the environment and ensure a sustainable future for generations to come. Let's begin with the impact of the rapid urbanization during the industrial era. Industrialization triggered mass migration to cities, leading to severe overcrowding and unsanitary living conditions. This resulted in the emergence of slums, where many workers lived in poorly constructed housing with inadequate access to water and sanitation. These conditions became a breeding ground for diseases. Moreover, social inequality deepened during this time as the gap between wealthy industrialists and impoverished workers continued to grow. Moving on the working condition, and during early industrialization, workers, including women and children, were subjected to extreme exploitation, working long hours in unsafe and unhygiene factories. Health hazards were widespread due to exposure to harmful chemicals and poor ventilation, leading to illness like tuberculosis. At this stage, labor rights were almost non-existent, leaving workers vulnerable to exploitation and abuse. The rise of industrialization also led to the loss of traditional livelihoods. Skilled artisans and craftsmen were displaced as factories and mass production became the norm. This shift disrupted small scale industries and local economic, further contributing to economic inequality. Industrialization significantly impacted the social fabric of communities also. Child labor became rampant, with children forced to work under exploitative conditions, depriving them of education and a normal childhood. Additionally, long working hours strained family structures, leaving little time for social or familial interactions, leading to a breakdown of traditional family life. Technological advancements brought both progress and challenges. Mechanization replaced human labor in many areas, leading to widespread unemployment among workers. This also created economic disparity, and industrialists gained significant wealth while many workers faced hardships. Nowadays, we may say that there is a new opportunities also available. If we talk about the colonial exploitation, industrialization also had a global impact through colonial exploitation. Colonized regions were stripped of their resources to fuel industries in Europe, leading to economic stagnation and dependency in those regions. Indigenous cultures were undermined and replaced by industrial economic systems, causing cultural destruction. The demand for raw materials and market fueled colonialism and imperial rivalries, often leading to conflicts and wars. We may see that nowadays in the world. Industrial advancements also played a role in warfare as they enabled the production of advanced weapons, increasing the scale and devastation of conflicts. If we talk about the ethical concerns, finally, industrialization raised significant ethical concerns also. Women and children were often exploited in factories as they were preferred for their ability to work for lower wages. The rise of mass production gave birth to consumerism, encouraging unsustainable consumption pattern and contributing to environmental degradation. In summary, while industrialization brought significant progress, it also posed serious social economic, and environmental challenges. Understanding these impacts help us to learn from history as we work towards more equitable and sustainable development in the future. As we progress through Industrial Revolution 5.0, we see a significant shift in priorities. This new era focuses on human-centric, sustainable, and ethical developments. It combines cutting-edge technologies like artificial intelligence, robotics, and IoT with a renewed emphasis on sustainability, inclusivity, and human well-being. In essence, it is about using technology to serve humanity rather than just driving profit and productivity. Industrial Revolution 5.0 addresses the pressing challenges of environmental degradation by prioritizing renewable energy resources such as solar, wind, and bioenergy. It significantly reduces dependency on the fossil fuels. Moreover, companies are embracing the circular economy also, focusing on recycling, reusing materials, and designing products with longer life cycles, minimizing waste, and extending product durability. Dear participants, green manufacturing is central to this transformation with energy efficient production methods, zero waste factories, and carbon capture technologies, helping to combat industrial pollution. Nowadays, you may see that the Tesla factories, we may consider, we may discuss on it later. Advanced IoT and AI-based monitoring systems further enable a real-time tracking of emissions and resource uses, ensuring compliance with environmental standards. Efficient resource utilization is another cornerstone of Industry 5.0. AI and big data analytics optimize supply chains and resource allocation and reducing waste. Techniques like biomimicry, which draw inspiration from nature, help create sustainable manufacturing practices. Decentralized production methods such as 3D printing reduce the need for a resource-intensive large-scale factories. Social disruption from previous revolutions are being addressed with ethical level practices. Enforcement of labor laws eliminates exploitative practices like child labor. Fair wage policies enabled by transparent technology, ensuring equitable compensation. Companies are also investing in community development through corporate, that is CSR, initiative, improving education, healthcare, and local infrastructure. Nowadays, we are all are talking about that is in corporate social responsibilities. To counter technological unemployment, Industry 5.0 emphasizes reskilling and upskilling. Training programs prepare workers for role in emerging fields like green technology and artificial intelligence, human-machine collaboration. Rather than replacement, ensures meaningful roles for workers while maintaining productivity and innovation. Education in this era extends beyond STEM, integrating humanities to create socially conscious innovators. Ethics in education ensures a responsible leadership in future industries. Lifelong learning platforms make accessible to everyone, knowledge accessible to everyone, enabling adaptability in an ever-evolving technological landscape. Sustainability remains a top priority. Industries are striving for carbon neutrality by adopting cleaner technologies and offsetting emissions. Global collaborations fosters resource sharing and addressing challenges like climate change. Circular design principles ensures products are easy to recycle and have minimal environmental impact. Health and safety are enhanced through innovations like wearable technology, which monitors worker health and alerts them to hazardous conditions. AI-powered systems provide predictive healthcare, preventive workplace injuries, and illnesses. Advanced filtration systems ensures cleaner air and waste in industrial and urban environments. To tackle urban overcrowding, Industry 5.0 introduced smart cities that efficiently manage resources, reduce congestion, and improve living conditions. Centralized work and disturbed manufacturing ease the pressure on urban centers. Nowadays, we are talking about the distributed system. We are not trying to centralize the system. We are talking about the decentralization of the system. We will take the example of the Oli car. Hence, if we talk about the vision of the Industry 5.0, the Industrial Revolution 5.0 represents a paradigm shift. It redefines technology's role as a servant of humanity, focusing on sustainability, ethics, and human well-being. It does not mitigate the adverse effect of earlier revolutions, but also pave the way for a better, more equitable future. This era is characterized by collaboration between humans and intelligent systems such as cobots. A cobot or collaborative robot is a robot that works with humans in a shared space. Advanced AI supports personalization and mass customization, while circular economy principles promote resource efficiency. Renewable energy integration further aligns manufacturing with global environmental goals. With this, right, we may easily understand the Industry 5.0, that is, it is the human-centric approach for sustainable and resilient system. In the next 6 and 7 slides, I will cover the real-world examples of Industry 5.0. For decentralized manufacturing, we may take an example of Oli autonomous shuttle. It was developed by the local motors, uses 3D printing and localized micro factories to produce vehicles. I'm just interested to share the video of the Oli shuttle.
Is not afraid to pump those. Oh, the stewards. Though their presence at first might seem like Oz's man behind the curtain, they're really only here for peace of mind, to bridge the gap between AVs and humans. State and federal regulations still require a human presence on board any autonomous vehicle, but Ollie is totally capable of operating by itself. Plus, it's definitely a perk to have someone on board to answer your many questions about how this robotaxi works. Like, how was it 3D printed? The steward on board my second ride informed me that this particular model of Ollie was made of about 30% 3D printed.
If we talk about the green manufacturing, we may take an example of the Tesla gigafactories. Tesla gigafactories integrate renewable energy sources like solar and wind to power their manufacturing processes, significantly reducing the carbon footprint of electric vehicle production. It focuses on sustainability in manufacturing with a focus on clean energy and efficient resource use. I'm just showing the recently in developing Tesla factory at Texas, USA.
Next 4 years. So what makes Giga will also speed up and expand testing of the Bay Area factory much more flexibility. Additionally, Tesla has publicly stated that it will also offer assembly for Tesla semis at its Austin plant, a hugely important foray into the long-haul EV market for Tesla. If Tesla wants to continue its meteoric rise, the new Texas factory will be playing a huge part in 2021 and onward. So, what do you think about the potential of Gigafactory Texas? How will it help Tesla compete with other companies in the highly competitive EV market? Let us know what you think in the comments. And before you leave, make sure you have subscribed to our channel. Until next time, stay safe and stay informed.
Due to limitation of time, I am fast forwarding my presentation. Addressing that is, collaborative robots for enhancing workplace safety and productivity, reducing the physical strain on workers. Universal robots designed to work alongside humans in manufacturing, performing repetitive or hazardous tasks, while human focuses on creative decision-making and supervisory roles. Addressing urban overcrowding and environment challenges through smart planning. Masdar City, that is in UAE, is one of the best example. Masdar City is a sustainable urban development that uses IoT, AI, and renewable energy to create an energy efficient and low carbon city. It focuses on clean transportation, water conservation, and eco-friendly building design. For addressing housing shortage while reducing the environmental impact of construction, Icon 3D printed homes in USA uses 3D printing technology to construct affordable, eco-friendly homes using sustainable materials, significantly reducing construction waste and cost. For tackling the growing challenges of e-waste through innovative recycling initiative, Dell closed-loop recycling program recycles old electronics devices to recover valuable materials like gold and uses them in new products, reducing e-waste and resource extraction. Leveraging technologies to enhance human well-being and healthcare accessibility. Babylon Health, United Kingdom, uses AI to provide personalized healthcare advice and diagnosis through mobile apps, improving access to medical services in underserved regions. Hence, we may say that each industrial revolution brought unique challenges, from labor exploitation to skill gaps and cybersecurity concerns. Industry 5.0 present opportunities to address these challenges, such as job creation in high-tech fields and leveraging digital tools for manufacturing. Balancing innovation with ethics remains the key. These two slides, we have compared the industrial 1.0, 2.0, 3.0, and 5.0 on the parameters: time period, key driving force, technology, focus, there's energy source, production philosophy, communication, worker role, environment focus, key innovation, value chain model, customer demand. So I am not going in detail due to limitation of time. Definitely, I will share the slide if anyone wants to review it or take the support from it, then definitely they may take. At last, at the end of the presentation, I may say that the journey from Industry 1.0 to Industry 5.0 showcases humanity's ability to innovate and adapt. Now we have the opportunity to harmonize technology, sustainability, and human creativity to create a brighter future. I will say to all, let us embrace this transformation and pioneer an era of ethical, human-centric development. At last, I will say it. Don't take pressure anytime, because in the industry, every minute there is a challenge. So don't take pressure, because health is the one of the topmost priority in Industry 5.0. At the same time, human beings also. Be sincere always, but never be serious in the life. These are the references that I used. And at last, I will say, हंसते रहिए, मुस्कुराते रहिए, और लाइफ को अपनी तरह से चलने दीजिए। नदी के बहाव को रोकने की कोशिश करेंगे तो काफी चेंजेस आ जाते हैं। तो अपनी गति में यदि नदी चलती रहती है तो सभी खुश रहते हैं। सो हंसते रहिए, मुस्कुराते रहिए। आई एम रियली ग्रेटफुल टू द ऑर्गेनाइजर, एंड वी आर ग्रेटफुल to really the Harshita madam, the moderator of the today's program, and both the coordinators for giving me opportunity to interact you all. And hope if you have any query and question, definitely I will try to address it. And if the time is not permitting, I will share my mail ID to the Anupma madam. Anupma madam may share that mail ID to all the participants so that they may discuss with me. If you have any problem regarding the research also, my area of the research is the production, process design. At the same time, I'm working on the optimization also. Nowadays, I have started to work on the
फायदा
biomedical
क्या
implants
मतलब क्या
also.
मीनिंग क्या उसे
So
कोलैबोरेट करने का?
in future, we may discuss on that topic also. Thank you to you all.
That's so thoughtful of you, sir. Thank you so much for sharing your valuable insight. Now, my request to all the participants, if you have any question, you can raise your hand or write it in the chat box. Is there any question? All the participants?